Okay, ready for day 2 here of working on this Joust. Can't remember where we left. Let's see, I have all the RAMs out and we were still getting the 132 error, so we have to fix that. I have a feeling it's one of the TTL chips that go in front of those RAMs from the CPU and stuff. And then we had, well, you can't really see that there. Get some light. I had put my Moon Patrol PCB in here temporarily, and we still need to repin this header, so I ordered some parts for that. And I think if we come over back into the little work area here, there's the original power supply, and so I did get some caps. We had already repinned all the headers and everything. Going to go ahead and do all new caps on it, and as well as put in the 5-volt mod from well, I first learned about it from Mark Spaeth at Cambridge Arcade, and he actually kind of details everything. I'll put a reference into what to do when I get to that part of the video. But we're going to put a pot in at R26 and kind of make the 5-volt adjustable, and then put it back in the game. And hopefully I'll do that tonight. The other thing is, I mentioned that I pulled the monitor out, and I hadn't noticed it. When I first powered it on, I wasn't getting any picture, and I heard some squealing. Well, not by me, but that neck board is cracked. I mean, that thing, I already took it off. But if you can see that, there is a cracked neck board. So have to probably fix that. And it looks like kind of I'm sure I can fix it, and I probably will. Just make sure all the connections are there. So add that to the list of a cracked neck board. Either swap it out with a different one, or repair this one. So the best I can. So all right, let's get started. Okay, so we had already repinned all the connectors and headers, and with the desoldering iron that I have, I don't know what, I don't have it plugged in obviously right now. Let me see. This is a 1.6 A1007 tip for the Hako 808. So it's a little bit bigger hole. When we're desoldering these caps, we're going to use a little bit different one, something a little bit smaller. Yeah, this is 1.0. You could go probably a little bit smaller than that. I also have a, this is also 1.0. Is that 1.0? A1003, 1005. So yeah, I can get even smaller, but I think this is fine for this one here. So obviously I'll only do this when the iron's off, and I usually don't film this activity. Let's see here if I can plug this in. I usually don't film the soldering and desoldering, but I figure I'll let the camera go and try to speed it up when I start actually doing it. The other thing is, while I was waiting on my parts, I'll zoom out a little bit. I was waiting on some parts and everything. I organized all my 0.156 molex connectors. So I got this little, it's like $3, this organizer from Harbor Freight, and I had a whole bunch of molex connectors, but they kind of were all stuffed in the same spots, and being organized definitely helps speed things up as well. So have all my different pins for the different gauges and everything. So cool. All right, I'll be right back and we'll start soldering. All right, I think we should be good here. Honestly, I had most of these caps in stock except for these big ones. So I just went ahead and ordered the kit from Arcade Parts and Repair. And he has everything, you know, kind of marked off, etc. But we're just going to do one at a time. This isn't like a monitor where I actually need all that. All right. 35 volt, 100 microfarad. Let's see, 100 microfarad. Right here. Alright, this is when we're going to speed up. Actually, I might actually end up testing a couple of these. I don't know, because I don't know if you guys can see that if it's zoomed in. Let's see. There we go. See how the bottom is kind of bulged out a little bit. Maybe that's just the way that cap was, but it's kind of bulged out a little bit compared to a new one. Yeah, so it might be worth actually measuring that. Double check the polarity there. Positive is long lead, negative is short lead. This one is 47. The silk screen's actually on the back side. Alright, 330. I have to pause and get some solder real quick. I actually kind of lied. I just went ahead and did all the caps off camera. But anyway, one of the things I didn't show on camera was in the Joust manual, and probably other Williams manuals as well. It says before adjusting the voltage, the 5-volt voltage output, always check the output at the supply for AC hum. The hum should never rise above 0.005 volts on the +5 DC line. And it just tells you how to do it. You know, you test with these with an AC setting, and you go, I guess, from ground to you know, the test points like test point 5, etc. So from ground to test point 5, I guess, or test point 6, etc. So I did do that, and it was 0.003. I did it off camera. But I'm curious to see if it's going to actually be any better. So I figured I'd hook up my little ESR meter here, which isn't a really good one. So I don't trust these readings, and you can get all types of different readings based off of the leads you have on here. So it's not great, but it gives you a good comparison. So the brand new one, just sitting like that, is 0.86. And the old one, let's see, is a little worse off. I mean, 0.13, which for 18,000 microfarad cap, we should be at like 0.06 or something like that. So, it could be my meter. It's also, that's just a range. It's not specific to a cap per se. So, but I would say that this one's still probably okay. It's not definitely super bad. I might even hang on to it just in case. It might save me from ordering that cap in the future. Let's test this other big one here. Now this might get a spark. Nope. Okay, good. Yeah, so this cap is good. This was 4700 35 volt cap, and that should be a, this is definitely a good cap right here. So, I mean, I'm going to keep this one too, because it's still, I mean, it reads good. But now let's check out one of these ones that I thought might be bad. Let's see here. And our power supply was working, so I don't know if it was actually, let's see, this cap is a 100 microfarad, so it's testing good as well, even with that little bulge at the bottom there. I bet all these caps were within spec. I mean, since we had it out, it doesn't hurt. Oh, this one here, that one looks pretty bad. What is that? 47 microfarad. No, I guess it is still within spec. Should be in the 1 point something range. Yeah, it's close. And I'm going to stop. I'm not going to measure all of these. But, I mean, let's see, this one's 1,000 microfarads. Well, that one had a little bit of charge on it still. Yeah, 0.09, less than 1,000. So, I mean, I bet all of these caps were fine. I'm going to keep the two big ones, just in case if I run across another power supply that I don't feel like ordering a whole cap kit for, I can, and these are really bad, I can go ahead and I could possibly use those in a pinch. But that's it. I just we're going to go ahead and put I'm going to do the 5 volt mod, so I'll be right back. Okay, so this is from the manual, and I'm not going to take credit for this. I'm holding this as well, but I just figured the manual says basically if you want to increase the power, increase the voltage, it gives you this like scenario. So which resistors that do you want to remove? So like if you want to increase voltage, you can remove R10 and even R24. And if you want to decrease the voltage, it kind of tells you to add R10, remove R24, etc. So when I look at the actual power supply, I see that, get it at a little bit of an angle, avoid the shadow if I can. Yeah, so R10 has actually already been removed. And that makes sense because we knew that there was a low power situation going on at the PCB. And so they cut out R10 already, which should have increased it. And Mark Spaeth actually has an excellent write-up on this at Cambridge Arcade. I'll link to it in the video. But basically, here's the schematic. And R10 and R26 work together in parallel for a resistance of 1.991K amount of resistance. And then you have R24 and R25 that work also in parallel together. And basically, he's got all the formulas down here, and I'm not going to, doesn't 100% make sense to me unless I actually did all the math out myself. But basically, he just says it's better to put the potentiometer at R26, because that's going to give you a voltage range, I think, of somewhere, to like 5.7 volts. Does he say that somewhere? Yeah, like 5.9 volts. So like if you put it at R26, the potentiometer, you'll be able to go from 0 all the way to 5.9 volts. But if you move it and you put it in like R20, 4 or R25 or the different places, you'll like R10. Actually, I might do it at R10, just because it's already out and it saves me from replacing a resistor. But if R10's removed, then your range would go all the way to 6.1 volts. So the idea here is that you don't want the range to be too high, so you accidentally put too much voltage to the PCB is the idea. But since R10 is already out, I'll probably go ahead and put the potentiometer there and just and use some glue, hot glue, to set it in place. That just will save me some time versus finding, let's see, R10 is a 51K resistor, I think. Yeah, I'd have to get a 51K resistor, put it back in R10, and then remove R26, which is a 5.1K resistor. So, yeah, that's what I'm going to do. I'm going to put it at R10 instead of R26, but you should actually put it at R26, I think, most of the time. So, okay, right. So right. I went ahead, I put it in the pot at R10, where I think R26 is the better location, but R10 will work as well. And so at the bottom, Mark's post that he had on his website, he says that if you do R10 instead of R26, your range goes all the way up to 6.1 volts. But if you do it at R24 or R25, it acts as a pull-up resistor, or variable resistor, since it's a pot, I guess. And you can go all the way up to 7.3 volts, and your low is like 2.43 volts. So anyway, that's what it says right there. So R26 is the better place, because on my board R10 was already removed. I just stuck it at R10 instead. And I might link to Peter's video as well from Arcade Repair, arcadepartsandrepair.com, because he has a better video, going through how to set up the pot and everything like that. So anyway, let's go ahead and put this in the cabinet. And I think what I'm going to do is measure. We're going to go through measuring AC ripple voltage on some test points and see if it's any better than what I got before, as well as see what the voltage drop is after I pin out that last connector. I think our voltage drop definitely got better when we put these headers on. We went from like 4.3 volts at the PCB to around 4.6. So let's see if we can actually get a better than that next time. So all right, I have the board back in the game, the power board, but I was learning something today. Always learning in this hobby. And so I have been using, from, I think, Great Plains is where I got them from, this style of molex connector. This is just a 2-pin, and this is a molex 41695. And the problem is all the keying plugs that you plug in here that I have are too big for this hole. This hole's a little bit smaller, and I think this is a little bit more expensive type of connector, and I don't have the keying plugs for it. So I need to actually remind myself to get the right keying plugs. This type of connector they're both from Molex KK series, I think. So, but this one here is series like 2139, and the hole is a little bit bigger, if you can see the difference. One's like kind of a softer plastic, one's a little bit harder plastic, and you can see the difference in the size of the holes there. Hold them the same direction like that. So the keying plugs I have fit the one on the left, not the one on the right. The other thing is that these trifurcon pins like this will not No, these will fit actually in both types of connectors. I'm pretty sure. But these types of pins, which I also had and used on most of my power stuff rework, instead of being like a trifurcon pin that actually connects on 3 sides, that makes contact, with oh my gosh, look at that thumb. Makes contact on 3 sides, if you can see that. This pin here makes connection on the header on basically all 4 sides, but it's definitely bigger and it will only fit into this molex 41695 that I have. So anyway, if you get the trifurcon pins, you're going to probably be okay, and you can use either of these connector types. But if you want to actually put the plug in for the key, make sure you have the right key plugs. So that is a lesson learned, and I will go back and let's measure some voltage. Okay, I'm not going to lie, I already powered it on, but because you never know. I was like, oh man, I hope I don't screw this up. But let's go ahead and power it on. I didn't screw anything up, I don't think. And we'll see what voltage we get. I'm hooked up to the 5 volt test points right now, which is ground. I think is test point 2, and then test point 1 is the 5 volts, and we're getting 4.038. The PCB is not hooked up, so we can go ahead and adjust our potentiometer here that's at R10 and see what range we get. So we could definitely go up. Wow, that is not good. We're only getting a max of 4.5 volts. So that doesn't sound good, does it? We should be able to get all the way up to 5.7. And it goes down to 0.7. Not what I was expecting there. So we might actually have to, that's interesting. I don't know why that is, unless there's something else going on. So let me go ahead and hook up the PCB and we'll measure the voltage there. Actually, what I could do is let's measure AC here. Well, that's definitely a lot better from a ripple standpoint, because I was getting readings before and now I'm not getting anything on the AC there on the 5 volt test point. We'll go to test point 6, I think that is 0.005. I think it said if it was over 700 millivolts, you would want to replace the cap. So I would assume that's pretty low. That's AC, and this is test point. Is that test point 5? Yeah. Test point 5 and test point 6 are reading the same. And we can go to, let's see, what's the 12 volt right there? If we're getting anything there, 0.003, but almost nothing, no AC voltage reading on the 5 volt, which is better than what it was, because I could have swore it was reading 0.003, if I'm not mistaken, before we replaced the cap. So unless, I wish I would have filmed that. Yeah, I'm pretty sure it was reading something, 0.003. So the fact that we can only adjust our power supply up to 4.6 volts is not good. So there's something going on with this power supply, or the fact that I have that resistor at R10 instead of R26, but I don't think that's the issue. So let me see what I can figure out or what to do next. I might plug in the PCB and just see if under load I can get more voltage going. Okay, I'm hooked up onto the chip with my meter, so we'll go ahead and power the game on. Everything's connected up. Double check here. That is, by the way, to the coin door lights and the coin lockout. So I don't know if it's like 20 something volts for the lockouts and 6 volts for the coin door or something like that. But that's why I'm not worried about it. The connectors look good, and it's insignificant to the game, pretty much. Everything else is in there pretty good. Just want to make sure. I think something else is going on with this power supply. So we'll power it on. So at the board, let me go ahead and adjust it up. So the maximum at the board I can get is 4.4 volts. Still enough for it to boot. If I hit the reset button here, you'll still see it go give me the same error. 132. It's kind of hard with that light, but we're getting 4.45 volts at the game PCB. That's as high as we can adjust it. And so what I'm going to do is turn the game off. Just remember 4.45 volts. We're going to measure 5 volts here and just see what our voltage drop is. So at least we'll see if repinning this connector helped a little bit from a voltage drop standpoint. So be right back. Okay, I think I didn't record the last little clip there, but anyway, while I'm hooked up to the power board, we're at 4.56, so about a tenth of a volt from a voltage drop, which is definitely better. I think we were at 0.3. We were a lot more than that to begin with, and then we got to 0.3 after we repinned most of this, and then once I repinned that one, we did a little bit better. So repinning definitely helped. I'm sure the cables aren't the greatest. They've been probably pretty stressed with heat over time, but we're just gonna have to see why we can only get 4.5 volts out of this. So have to troubleshoot it some more, troubleshoot this board. There's gotta be something, a bad component or something wrong with it. And the other thing is I do have this working board here so we can compare. Like, is that even the right bridge rectifier? I don't know. So what else would be causing it to not put out a full 5 volts? So all right, we'll be back in a little bit. I think I figured it out, and I'm not going to be able to explain it because like I said, I barely understood it myself. But you cannot put this resistor here at R10. So with leaving R26 in with R10 at 10K, we were getting a parallel resistance of 3.38 K, and we need to be, just to get back to the factory spec, we need to be around, what do we need to be around? I think 4.64 K to just be where the factory is. So what I'm going to do is, I'm not going to put R10 back in. I'm just going to remove R26 and move the pot to R26, and then that should give us a, let's see here. Mark actually has that on his diagram. That should give us a parallel resistance of 8.36. So you can see the difference there, and that should allow us, no, that should give us, I have to use my cheat sheet to do the parallel resistance. Should be, I think, it'll give us a parallel resistance, obviously, of 10K when the pot's maxed out, because there's nothing in R10 anymore. So it will be higher than the 8.3 if we left R10 in, but R10 was already removed. So we're going to go from 0 all the way to 10K, and that should give us the voltage adjustment that we need. So I basically screwed up by putting that in R10. It needs to go into R26 and not R10. And I think Peter in his video that says to put it in R25, but then I think you can go all the way up to 7.3 volts according to Mark's formulas and stuff. And I'm not going to do all the math to try to figure it all out and double check it, but it looks right to me, and I just we learned something, right? Make sure that goes into R26 and not in R10. And your parallel resistance on that part of the circuit, which is on the part going from ground to the that pin number 5 there. So that needs to be somewhere in the range of 8.3 K or higher, probably parallel resistance. and because the default factory with all the resistors in would be around 4.645. So, all right, that probably didn't make any sense, but I am going to remove this from R10 to R26 like I should have done to begin with, and we're going to have a good voltage going to our board. Okay, I have my resistor in the correct location. Put the board back in there, and I don't have the PCB plugged in because I was just doing work on the power supply. So you definitely want to test your power supply again before you plug in your PCB. All right, now we're at 5.1 volts when it's basically at the midpoint. And let's see how close Mark is. We can get all the way up to 6 volts. So yeah, R10 was already removed, so we know that this thing was a little bit off to begin with, and we should be able to adjust it all the way down to 0. Whoops. Pretty close, 0.7. So we want to put it probably around 5.1. And then plug in the PCB, because I think we have like let's leave it like that. So we should end up with like about 5 volts on the nose when we plug the PCB in. Before we do that, yeah, because now I'm putting a little bit more, I guess, load on the power supply or whatever, because we're putting out a little bit more voltage. So we do have something reading here, 0.001 of AC, so ripple voltage to that. And let's measure it to TP5 here. TP5, 0.005 and 13 volts. That definitely should never go below 11 volts, is what the manual says. So at test point 5 and test point 6 is negative 13. So, all right, so we're looking good on the power supply. Let me pause for a second, hook it up to the PCB and plug the PCB in, and then we'll measure voltage there and see what our voltage drop is. So real quick, we're at 5.113 at the power supply. So, all right, I have it hooked up to the PCB. I have my multimeter leads hooked up to the PCB on a TTL chip, and we're reading 4.98 volts. So from 5.1 something to 4.9. So we could adjust it just a little bit higher, but it's pretty much right on 5 volts. So we'll just leave it. How about right there? I mean, that's 5 volts on the nose. So power supply rebuild is complete. Probably should put some hot glue or something to hold the pot in place so it doesn't get moved. It's pretty sturdy though. I mean, it's not, unless somebody really moves it, it shouldn't go anywhere, but it's just a safety thing. And now we can go back and focus on the RAM chips and troubleshooting that. I actually have a RAM tester that I might build out in a different series of videos and test all the RAM chips or test the bad ones or something, because instead of putting them in my Stargate buffet, said, hey, you should have tested those in a tester and saved your game. And I actually have the tester, but I've never actually built it. So I might do that. I don't know about putting it in this series of videos, but I might actually do that next and then come back to this RAM issue. So, all right, talk to you all later. Bye. Okay, everybody, it's the next day, but it was bothering me how much of a jacklick I was putting this potentiometer at R26. This is the board that I removed. This is my Moon Patrol board, so the other board's still in the game. But remember, R10 was already cut out, and I initially put the potentiometer at R10 and left R26 in there. On Mark's write-up, it clearly says if R10 is also removed and you put the potentiometer at R26, the voltage adjustment would rise to 6.1 volts. So he already says like you should have R10 removed if it is already removed, to put the potentiometer at R26. But me not thinking clearly, put that at R10. Now what I should have or could have more easily done, instead of moving it from R10 to R26 like I did on the other board, I could have just removed R26 and left the potentiometer in at R10. They're parallel resistance, so if R10's already removed, all I needed to do was put the potentiometer in at R10 like I did and cut out R26, and that would have been the quicker solution, and I would have had the exact same solution that I ended up with. But anyway, so that was really not like a big deal or anything, but it's, I was just being a jacklick. And the other thing I thought was interesting is I wanted to actually work on the formula that Mark laid out here. So he's talking about the voltage reference generation, and that you basically take the parallel resistance of R10 and R26 with the parallel resistance of R24 and R25, and use this formula basically to calculate your voltage reference, I guess. So what I did is I kind of just, hopefully my handwriting here is okay and legible. You take the 7.3 volts times the 3.38K, which was the parallel resistance I had when I had R10 at 10K, and when the potentiometer was in location R10 combined with R26 at 5.11K, my parallel resistance was 3.38K. So I take that, and I know math is easy for most people, but not for me anyway. But you get this 24,674, and you divide that by the sum of the all four resistors. So R10, R26, 3.38K, plus the R24 and R25, which is 1.911K. That's 5371. Divide 24,000 by 5371, and you get 4.59 volts, which when we were actually doing the adjustment, our power supply was maxing out at 4.6 when I had the potentiometer in location R10. So anyway, it was bothering me enough that I wasn't reading carefully enough, and I wasn't taking the time to fully understand what was going on. But it was sometimes making mistakes allows you to do a little bit more learning. So I think I have it down and understand there. Anyway, that is it for this. I just wanted to come back. I have to add it and re-upload this video now because it was bothering me so much. But anyway, if you put it in R26, and leave R10 in, that's fine. That's actually the preferred way. If R10's already out, you could put it in R10 and cut out R26, or put it in R26, whatever. So that's the preferred, I think, solution. So you do get a little bit more with R10 out and the potentiometer in at R26. You do get a little bit more voltage range, I guess, out of it. You could get up to, like as Mark says here, 6.1 volts. So anyway, that's it. I'm done. Adios.